So on the literal equation side, just pointing out, you have to just choose any 10 to solve. I'm going to choose 2, and then you find the other 8. So I'm going to start with 2, and I'm going to do this on a separate sheet. Problem number 2 is A equals quantity of 2 times the quantity of L plus W, and it wants you to solve for W. So we want to get the W alone. There's actually 2 ways to do this. So I'm going to show you both methods. Method 1. Method 1 is like, okay, I see parentheses, so I want to distribute. That's a very common thing. People want to distribute when they see parentheses, and there's nothing wrong with doing that here. It's not always the best thing to do, but you can do it here. You can distribute the 2. And now I'm going to need to leave, I still want to leave the W where it is, so I'm going to subtract the 2L to get it away from the 2W. So I've got A minus 2L on this side equals 2W on this side, right? And then divide by 2. So W equals A minus 2L all over 2. Okay, so that's method 1, and that's perfectly fine. Method 2. Method 2 looks at this slightly differently. It says, well, what's happening to my W? First it's being added to L, then it's being multiplied by 2. So if I want to undo that in the opposite direction, then the last thing that happened to my W was to multiply by 2, so the first thing I'm going to do is divide by 2. And what I do to one side, I do to the other. So on this side, I have A over 2, and on this side, these cancel, and I'm left with L plus W. And now I just have W being added to L, so I need to subtract the L. So A divided by 2 minus L on this side equals W on this side. Now, you'll notice that this and this slightly different, right? A minus, this one up here, this solution up here says A minus 2L over 2 equals W. And this says A over 2 minus L equals W. So I want to show you that this is actually equivalent. If you distribute the division of the 2, then this lands you at A over 2 minus, and then those 2's cancels L. So they're actually the same thing written as equivalent expressions. So either one is fine, whichever way makes the most sense to you. I'm going to do one other problem on here, and then the rest is for you to do. I'm going to do problem number 19. And again, I'll write that over here bigger. So problem number 19, we have x equals 2y minus z over 4, and we're supposed to solve for z. So here, there's nothing to distribute, no like terms to combine. There's only one z, so there's no factoring to do. So what we want to ask ourselves is, what's happening to z? Well, first it's being subtracted from 2y, and then it's being divided by 4. So I want to undo the division by 4 first. And I do that by multiplying both sides by 4. So I've got 4x equals, and then these 4's cancel, 2y minus z. Okay, the next thing that's happening, again, z is being subtracted from 2y. The best way to undo this is actually to treat this kind of like an addition of a negative and just get rid of this 2y. I want to take this 2y, and if I subtract it, it will cancel. So I subtract the 2y, and 2y minus 2y cancels, leaving opposite of z. So that negative stays with the z. And then on this side, we've got 4x minus 2y. And then the last step, so it's this negative that makes it kind of tricky, right? You got to remember to keep it with it. And then you got to get rid of that as well. The way we get rid of a negative is you can take the opposite of both sides. And you can either think of it like that, I'm just going to take the opposite of everything, or you can think of it as dividing by -1, because that's really a -1 in front of the z, right? So on this side, then that leaves plain z. And then on this side, I need to distribute that division. So 4 divided by -1 is -4x, and a negative divided by a negative here is positive, so positive 2y. So that is Problem number 19. So you choose 8 more of those literal equations to solve.